This is PreCalculus 12, Chapter 7.5. We're going to do the proof of the cosine addition formula. So cosine alpha plus beta equals cosine alpha times cosine beta minus sine alpha sine beta. Now, before starting the proof, I need to convince you of one thing, that this angle and this angle are the same, therefore this would be alpha. We've constructed this so that this is a right angle and this is a right angle. These two are corresponding angles because these are traversal lines. So we have 1, 2 angles that are the same, therefore the third angle of the triangles must be equal. And now we can begin the proof. So we'll start off with the literal definition of cos alpha plus beta. This is alpha and this is beta. We're adding the two angles together. We're doing cosine, so that's x over r. And we see that this definition is true. OB over OP. Next, we're going to break up OB. It's defined as OA, and we're going to subtract off AB. So that's that definition. We can see that that's true. Next, we're going to do a small substitution. AB is parallel to QR, so they're the same length. So we have QR over OP now. And here comes the tricky part. Let's look at OA and OP. There's no trig relation here. We want to multiply by 1, so something over itself. And we want to pick a common side between these two triangles. So that's a common side. And now we can see that we have OA over OQ. This is a cosine relationship. And if we look at OQ over OP, that's also a sine relationship with angle beta. And this one's with angle alpha. So we have cos alpha times cos beta. So that relationship is done for the first term. Next one, we have QR and OP. This one's a little bit trickier, but there's a common side that we can multiply by. That's PQ. So we're multiplying by PQ over PQ. We're not changing anything. Now let's rearrange this. If we look at QR over PQ, we see that this is the sine ratio for alpha, because this is the opposite over the hypotenuse. If we look at the beta triangle, we see that this is opposite over hypotenuse, so that's a sine relationship as well. So we have minus sine alpha, sine beta. And that completes this little proof. I will leave it as an exercise for you to verify that sine alpha plus beta is also a valid identity. And that completes this mini lesson.